Okay, so today let's take a peek at the different types of chemical reactions. There are a few different ones that I want you to know, but we've been playing with chemical reactions. We've been doing them, we've been balancing them, we've been actually performing some of them in class. You've seen some of them throughout the year. But now let's dive a little bit deeper and define what are they? What do they mean? So, things that you need to know that a chemical reaction is when the formula changes. You get different stuff on the other side of that reaction arrow. So as we do a reaction, on the left side we have our reactants. That's the stuff going to be reacted, the stuff before the reaction happens. And then we have our products, which is the stuff after the reaction happens. Then the other thing that we need to remember is the law of conservation. I have to have the same type of stuff on either side. It can just be arranged differently. So if I have carbon on one side, I have to have carbon on the other side. It can be in a different formula, but it has to be on both sides of my equation. Okay. So the 5 types of reactions are synthesis, decomposition, single replacement, double replacement, and combustion. Now, just looking at the titles, they're already giving you a clue in what they mean, because this is probably one of the more literal things in chemistry. So let's take a peek at what these reactions are doing. With a synthesis reaction, we're building up. If you have a synthesis of ideas, what's happening is you're synthesizing it, you're bringing it all together. So I like to think of it as just stuff coming together. You're going to end up with fewer or more complex products at the end of this reaction. So over here, I have 2 reactants. I have sodium and I have chloride. Remember, reactants meaning this side of my reaction arrow. And then on the other side, I have one thing. I have fewer complex products. So these 2 things came together, which means that we have a synthesis. With a decomposition, we're breaking it down. So we're decomposing this formula. So we're going to have multiple and simpler products. Okay. So let's look, it's just the reverse of synthesis, right? So we have something being broken down into more and simpler things. So I like to just look at it as it's the opposite of synthesis. Now, you don't want to get caught in that trap, though, because it doesn't just have to be one thing. You can have more things reacting. It's just that you're going to have more products over here, and they're going to be simpler than this. With a single replacement, I'm literally just replacing one thing. So one element is just replacing another element. So I always talk about this as somebody cutting in on the dance floor. So somebody is seeing 2 people dancing. That's my element. He's looking over there. He wants to go dance with that person, so he goes over and bumps that other person out of the way and takes over. So over here we have the element iron, and we have this copper chloride, so this copper 2 chloride. And iron is going to come in and kick that out of the way. So on the other side, we have now iron 2 chloride, and we have this copper hanging out by itself. So that's what we're looking for, one thing. So I have one element on this side, I have a different element on this side. I have one type of compound on this side, I have a different compound on this side. But the key is if you see an element over here and you see a different element on this side, you had a single replacement reaction. With a double replacement, you're just doing it twice. So this has to be between 2 aqueous compounds. So I have to have 2 different things going in there that are aqueous. Aqueous just means that it's an ionic compound that has been dissolved in water. And I want you to just think about this as now we have 2 people dancing. We have 2 couples dancing near each other, and they trade partners. What's interesting is one of these partners, so one of these new couples, are going to stay dissolved. The other one is going to be forming a solid, and we call that solid a precipitate. So that's what I want you to know. We make a solid. 2 liquids come in, 1 solid comes out. Now, we can see that down here in our example, where calcium chloride is going to switch places with this nitrate. So calcium's going to swing in and start dancing with nitrate. And over here, our silver is going to switch places and start hanging out over here with the chloride. And that makes the solid. So silver chloride ends up being a solid in this case. Okay. So we have two formulas, so two compounds. And on this side, we have two different compounds. That's how we can identify that. Combustion is great. This is the easiest, I think, to identify because a lot of it doesn't change. In the beginning, you're always going to have some type of hydrocarbon, which just means it's carbons and some hydrogens stuck together. It could be an amount of carbon and an amount of hydrogens. They're going to combine with oxygen gas. So you can even see down in the example, I have some amount of carbons and hydrogens stuck together. It's reacting with oxygen gas. And on the other side, I'm always going to see carbon dioxide, water, and energy. So if you see carbon dioxide and water on one side, chances are you're looking at a combustion reaction. You just got to look over here and say, oh, these are what the two things went in. This is combustion. It's a hydrocarbon. It's oxygen. On the other side, we're always going to get the same thing. We're going to get carbon dioxide, water, and some energy. So let's try this out. So here are a few different reactions, and I want you to pause the video for a moment and try them. See if you can figure out which one of the 5 each one of these things are. Okay, so our first one here, I see a formula, and it's being broken down into an element and also a diatomic element, so there's 2 elements there. It looks like I had one complex thing and more simpler products. That's going to be our decomposition. It's decomposing, it's breaking apart. Okay, let's look at our next one. We have sodium chloride and silver nitrate. So we got these 2 compounds going in. We have 2 different compounds coming out, so 2 ionic compounds. I didn't say it, but there is a solid that forms. This is a double replacement reaction. Okay, so the partners are just changing with each other. All right, let's look at number 3. We have an element here. We have a diatomic element here, so chlorine. So these are reacting together, and I'm getting this nice compound right here, this molecular compound, and that is a synthesis reaction. It's 2 things coming together. So we have fewer, more complex stuff on that product side. So let's look over here. I have an element. I have an ionic compound. A reaction happens. I have a different ionic compound and a different element. So my key is here, element, they're different, which means that this was a single replacement reaction. All right, and then last but not least, we have this one. We got a combination of carbons and hydrogens stuck together. It's reacting with oxygen. And on this other side, I'm seeing carbon dioxide and water. And again, if you're seeing that pattern, you're going to see combustion because you have carbons and hydrogens, oxygen. On the other side, we're going to get carbon dioxide and water every time. So those are our 5 types. If you have any questions, please don't stop from asking yourself. So ask in class or whatever you need to do. And we will see you soon. All right.